Hi everybody, it's Mr. Hamilton here, and welcome to this video on inverse of a quadratic function example. So let's look at one question that you might encounter, and I'm going to address some misconceptions in here as well. The question says this: determine the inverse of f of x equals 3 times x plus 4 squared minus 5, where x is less than or equal to negative 4. And we'll see why that restriction is so important in a minute. We'll come back to it. And it says graph both f of x and f inverse of x, so that inverse function, on the same set of axes, and then identify the domain and range of both functions. So here we go. So part A is relatively straightforward. We're going to first let y equal f of x, and then we're going to switch the variables. So we're going to get y equals 3 x plus 4 squared minus 5. There is a misconception coming up, so bear with me here, even if we find it fairly straightforward. We're now going to switch x and y. And so what we're going to get is x equals 3 y plus 4 all squared minus 5. And so what we do to rearrange an equation is we do the reverse order of operations, and that is SAMDEB, because BEDMAS is the normal order of operations if we're solving for a number, but here we're trying to do the reverse order to rearrange it. We're not solving for a number. So I'm first going to add or subtract. Well, what can I add or subtract? Well, it's the 5 here, so I'm going to add 5 to both sides. X plus 5, and we get 3 times y plus 4 all squared. Well, now I'm going to do the multiplying or dividing. Well, there's my 3 out front. I'm going to divide by 3. That's going to cancel it out and give me nothing in front of the brackets now. And then I'm going to have y plus 4 squared. So the next thing I'm going to do, the third thing, is the exponent. So I'm going to take the square root. But remember, when we take the square roots, this is super important, we have plus or minus the square root. And the reason for that, I'll come back to this here in a second, the reason for that is if I had x equals 9, x squared equals 9, let's say, then if we take the square root of 9 is positive 3, but we could also have an answer of negative 3, because it could be positive 3 or negative 3. If it was negative 3 squared, it would still give us 9. And so that's why we have both the positive and the negative. So with that out of the picture, let's just continue on with this question. The last thing I needed to do is what's in the brackets. So that's the fourth step. The y plus 4 is in the brackets. So now that I have nothing outside the brackets, I can just get rid of the brackets and I can subtract 4 from both sides. I'm going to write that negative 4 out front. So I'm going to get negative 4 plus or minus the square root of x plus 5 over 3 is equal to y. And so in general, you'll see the minus 4 written out front. You could write plus or minus the square root of x plus 5 over 3, and then after the square root, minus 4. That would be also correct. But by writing the negative 4 out front, we know that it's not under the square root. All right, so here's where it's not a function, it's not an inverse function yet. So how do we make it f inverse of x? Well, the way we do that is we look back at this restriction right here. And we'll see this in a minute when we graph this. F inverse of x is going to be switching the domain and range with the domain and range of the original function. So the original domain was x is less than or equal to negative 4, which means that the f inverse of x must be less than or equal to negative 4. So how do we make this whole thing less than or equal to negative 4? Well, the other reason we have a negative 4 up front is so we can see if we add a value to it, it becomes negative 3, negative 2, it becomes bigger, eventually to positive values. If we subtract a value from it, it makes the whole thing always less than or equal to negative 4. So in this case, we're doing subtraction only due to the restriction. And we're always going to have to make that decision based on the restriction. Are we going to add it or subtract it from the number in front of the square root? So this brings us to part B. And in part B, it asks us to graph f of x and f inverse of x. And so we've never graphed f inverse of x before, but let's start by graphing f of x, and I'll walk you through how to do the inverse. F of x has an a value of 3. It's in vertex form. F of x is in vertex form. It has an a value of 3, meaning it's going to have a vertical stretch by a factor of 3. It doesn't tell you have to identify what these all do, but just so it's clear for everybody. We also know that the h value is equal to -4 because the general form is x minus h. That would be subtracting a -4. So that's going to shift 4 units left. And we have the k value of -5, which is going to shift 5 units down. So with all this in mind, let's go ahead and graph y equals x squared, and then we'll apply this transformation. We all know that by now that y equals x squared has these key points. And we're always going to start with these 5 key points. Then we take that graph and we multiply all the values by 3. So this is y equals x squared. Now we're going to stretch it vertically by a factor of 3. So I'm tripling all these values. So if I had a value of 1, now I have a value of 3. And if I had a value of 4, now I have a value of 12. So it's a little bit off the grid there. And then 0 times 3 is still going to be 0. So that's the graph of y equals 3x squared. So now we shift this 4 units left and 5 units down. So we take this. I'm going to start with the vertex. 4 units left, 5 units down. Brings me right to there. And then you can just use that shape by over 1 up 3, over 1 over 2 up 12. So if I start at -5, I'm going to go all the way up to +7. And so there is the graph of the function y equals -3, or +3 rather, x plus 4 squared minus 5. So it looks like, okay, we know how to graph that, but here's the problem now. This has a restriction that x has to be less than or equal to -4. So that means that everything on this side doesn't exist. Only the left side of that function exists. And the reason we have that is because when we flip this in a minute, it doesn't form a function, doesn't pass the vertical line test if we have an entire parabola. So let's go ahead and just clear it up here and see what we get. So I'm erasing that half of it, and then the vertex is right there. So now, how do I graph the inverse function? Well, I graph the inverse function by graphing it, reflecting all the points about the line y equals x. This is the line y equals x. And so we reflect over the line y equals x. The other way you could think about it is you switch the x and y of the points. So what I'm going to do here is I'm going to start by, I have a point down here. This point originally was -4, -5. And that point's going to become -4, -5, -4. So now -5, -4 is right there. The next point I had was, just write that, -5, -4. So the next point I had up here on the blue was right there, and that was the point -5 and -2. And so now I'm going to go instead to -2 and -5. -2 and -5 is right here. And the next point, I originally had -6 and 7, you can see up there, and that's going to become 7, -6. 7, -6. And so now what I'm going to do is I'm going to join those 3 points together, recognizing that the point that was originally the vertex is the new endpoint of the new function, and this is f inverse of x. I just flipped all the points about the line y equals x, and so it almost looks like 2 wings coming off the line y equals x. So if you need to, go back and take a second yourself and just see that I've switched each of those points from the blue function to the black function, the inverse function. And last but not least, it's asking for the domain and range of each function. So let's give these for f of x and for f inverse of x. So f of x, the domain, x is a set of all real numbers, and we had the restriction given that x had to be less than or equal to -4. Now we can look at our function, the blue function there, and we can see that the original function also had a y value that was restricted. The y value never went below -5. We can see that from the graph. So I'd recommend graphing it to see it. It really helps to pull it out clearly. So f of x is a set of all real numbers such that f of x is greater than or equal to -5. Well, what happens with the inverse function? Well, we already said that the domain and range were going to switch. So the new domain, so because the original domain of the original function was this, then that means the range is f inverse of x is a set of all real numbers such that f inverse of x is less than or equal to -4, as we've already identified. And then the x value is a set of all real numbers, and it switches with the original range. So x is greater than or equal to -5. And if you actually go back to this function right here, think about if you put -5 or anything bigger than that, it gives you 0 under the square root. But if you put -5 or anything smaller than -5 under that for x, it's actually going to make it a negative value under the square root, which is not possible. So that's why that restriction comes. But once you've identified the restrictions on f of x, you literally switch those for f inverse of x, and there you have it.